Okay, so in this problem, we are learning in Calculus 3.2. This time we're doing the quotient function. And this problem is actually easier. It's tough to come up with a good practice problem that's meaningful for a quotient. But what they're intending you to do is to rewrite this by dividing every piece by x squared, which is perfectly acceptable because in order to add or subtract fractions, you need the same denominator. So what they're trying to get at is that this is the same as 2x minus 3 plus 2x to the negative second power. So then the derivative of this is simply 2 minus, that would be 0 right there, so you don't have to write it, but then this would be minus 4x to the negative third power, which is the same thing as, let me write 2 for a second, 4 over x cubed. Well, if you get the same denominator, it would be x cubed over x cubed. So you're looking at 2x cubed minus 4 over x cubed. And there might be a little bit more simplification to happen there. But just like in an earlier problem where we have, Leibniz and Newton were coming up with different rules, there's also a quotient rule. Now, the reason why we say quotient is because that's the fancy word we used a long time ago to say divided. So if you have a division problem with a independent variable on top and an independent variable on bottom, you can do this problem. So I'm just going to come up with random variables. Don't be mad about this, but I'm going to call it p of x is equal to g of x over h of x. I'm trying to avoid using f like I did in the previous video. So if this is true, provided that h does not equal 0, that's sort of a big deal here, but I'm not going to write that down. The derivative is equal to, it's a lot similar to the product rule where you do the derivative of the one piece, you leave the bottom piece alone, minus you take the derivative of the bottom piece, you leave the top piece alone. Those are multiplications, by the way. Notice that it's minus instead of plus as well. All over the denominator squared. So as we look at this problem, if I were to ask you to take the derivative that way, well, the derivative of the top would be 6x squared minus 6x times the derivative, leave the bottom alone, minus the derivative of the bottom, leave the top alone, all over the denominator squared. Well, let's do some simplification now. Well, as you distribute, you would have 6x to the fourth minus 6x to the third minus, that would be 4x to the fourth plus, 6x to the third minus 4x, try to squeeze it right there, all over x to the fourth. Well, if you look in the numerator then, you can see that the 6x cubes will cancel. In the numerator you have 2x to the fourth minus 4x all over x to the fourth. And you might not think about it, but you could factor out an x in there in the numerator. And you could take out x, like x times x cubed. I don't know if that helps anybody. And you can see that we are left with exactly the same thing that we had up here. 2x cubed minus 4 over x cubed. And this always works. So why do we do that? Is we can't just divide these pieces. Okay, we can't just split them up. So this is the best way that we can take the derivative of this. I guess I should point out why are we doing the derivative. It's a tangent line, so we need the point. Well, they give us the x coordinate of the point, -2. We got to figure out the y coordinate, and then we need to figure out the derivative when x is -2. That way we can find the slope at that point. So let's go ahead and find when x is -2. 2 times -2 is -4, minus 1 is -5. I'll simplify later if it's special. And plugging in down here, -2 plus 5 is 1. So it's just -5 over 1. All right, let's actually find the derivative now. So the quotient rule tells you to take the derivative of the top, leave the bottom alone, minus the derivative of the bottom, leave the top alone, all over the denominator squared. So you don't have to simplify because we only want g prime of -2. So I've had students that struggle to simplify. You can if you want, but all you have to recognize is when you plug in -2 in for this x, -2 plus 3 would be 1. So you just have 2 right there. And then minus, what's this? 2 times -2 is -4, minus 1 would be -5. Don't forget it's minus -5. And then plug in -2 down here, plus 3 is 1, squared is just 1. So the slope at that point would be 7. So as we write our equation, y equals the slope, x minus your x-coordinate, and then minus, well, I guess plus the y-coordinate, but it's -5. There you go. Feel free to pause this video at any point, really soak this in, or try it on your own and then see if you can get an answer that matches. So we are ready to move on to the next page. And now we can actually use the quotient rule to solve some pretty interesting problems. But anyway, let's first verify, because sometimes we have verify problems where all they're doing is looking at your work. So the derivative of the top is 2x plus 3. You leave the denominator alone, minus the derivative of the bottom, leave the top alone, all over the denominator squared. Well, that doesn't look like our final answer. So what do we need to do then is go ahead and FOIL that. So this is how they get you to show some work. 2x cubed. What else do we have? I guess I need to just work it all out. I was trying to look for a shortcut, sorry. Minus 2x minus 3, and then distribute that -2x to each. 6x squared minus 4x. The denominator is still the same. So as I'm looking at it, I see 2x cubes cancel. Let's see, I don't see anything else that cancels. But let's look at the final goal in mind, that I need to change the denominator somehow. Well, let's look at this denominator specifically. And I hope you notice that that's a difference of squares. So what should happen based off of that is you have x plus 1, x minus 1, each being squared because it's squared. So as I'm looking at that, I'm thinking about, well, how do I get rid of things? Well, x plus 1 better get rid of something in the top. So I would simplify that first. What's that? 3 minus 6. So in the numerator, I'm just looking at, I'll write it over here, -3x squared. What's that? -2x minus 4x would be -6x. And then minus 3. Ooh, well, everything's factorable there. So as I'm looking at that, I could factor out a -3. That would be x squared plus 2x plus 1. And maybe I'll rewrite the denominator as x plus 1 squared and x minus 1 squared. I hope you're okay with that. Because now that I'm looking at the numerator, x squared plus 2x plus 1 is equal to x plus 1 squared. You can FOIL it out if you don't believe me, and you're left with what we said we would. So a pretty neat problem, as long as you understand everything that's going on. So again, pause the video, make sure that you understand as you do this, and work it out. I think what they want you to do is I think this author wants you to recognize that the quotient rule is just the product rule in its simplification, because in case you didn't know, you could have rewritten this problem. I'm not going to work through with this. This is a good investigation problem, so I'm just going to ask you on your own to investigate. Will you get the same answer if you were to rewrite this problem as x squared plus 3x plus 2 times x squared minus 1 to the negative first power? Well, we do have an issue because I have not taught you a specific rule on this one. So how about don't investigate this one until you learn the chain rule. So this might be a little misplaced to look at this. So let's not mess with that yet. Okay, so we can algebraically analyze that later. So let's move on to special things we can now do with the quotient rule. And I think I have enough time to get through this. Because remember, your definition of tangent is sine over cosine. Because we have not talked at all about what the derivative of tangent is. We just know that the derivative of sine is cosine. We'll leave the denominator alone. Minus the leave sine alone. And the derivative of cosine is negative sine, all over the denominator squared. Well, as you look at your numerator, I'm just going to write it right above it, that cosine times cosine is cosine squared. And sine times sine is sine squared. Well, as you look at that, this is a special trig identity. Sine squared plus cosine squared always, always, always equals 1. So we're left with 1 over cosine squared. So what I'm telling you, and you'll probably memorize this because you'll see this often enough, that the derivative of tangent is secant squared. And I can do the same thing with cotangent. All the work is pretty much the same. Cotangent by definition is cosine over sine. So now we can use the quotient rule, where the derivative, well, the derivative of cosine is negative sine. Leave the denominator alone. I hope you're okay. I'm just going to write sine squared minus the derivative of sine is cosine. Leave the top alone, so there's 2 cosines right there. All over the denominator squared. Well, in the numerator, you can factor out a negative 1. And just like before, you're left with sine squared plus cosine squared, which is equal to 1. I'm just going to cross it off because being equal to 1 is the same thing as canceling. So what we're left with for the derivative of cotangent is negative cosecant squared. And at some point, we will do this enough that I think that these 2 rules, you will just memorize these values. At least I haven't memorized. That doesn't necessarily mean you will. However, we will do them enough that I think you'll memorize. The derivative of tangent is always secant squared, and the derivative of cotangent is negative cosecant squared. And I'm not going to try and rush anymore, so I'm going to pause it right here and meet you up with the second video.